Hi, my name is Victor Borges from DNVGL Software, and this video is about the multi-product feature in Maros. So the multi-product feature in Maros is probably one of the most important features we have in Maros, right? Because it allows us to check the capacities and transient capacity we have for each one of the product related systems, right? So what we're going to do today, we're going to build up a multi-product model, and we're going to do some analysis on it, right? So as with any other model, we need to start by creating a new model, and we need to press new there. So this is the simulator parameters window, right? So as we described in the video, building up your model in 6 steps, this is where you define the basic parameters of the simulation. So for this particular model, we're going to assume a 10 years of system life. So pretty much saying that we're running this for 10 years, it's starting from 2016. We're running 100 lives. So we are estimating 100 different life cycles of 10 years, and we're going to take the average of that. And the next step is defining the products area, right? So this is where we need to define the multi-products, right? So the first thing we need to do, we need to define the primary product for us, which in this case is oil, right? So we're gonna have a oil, water, and gas system, right? So it's very simple. Maros can take up to 10 different products, right? So today we're gonna start with a simple one. And we're gonna assume the green for oil, and you're gonna see why in a second. I'm gonna add a new one, right? I'm gonna add water, right? And for the water, we need to assume the same unit for as the oil, right? And the reason is because when design engineers are working on separation systems, they need to use the total liquids to design the separation system, right? So we normally assume that the gas is dissolved into the liquid formation, right? And that's why you need to use the same units, so Maros can calculate how much is the peak capacity of the liquids, and therefore how much you need to have to design your separation system, right? We're going to use water, and we're going to use blue to define the water, right? So we're going to add another product here, and the next one is going to be gas, right? So let's set up the gas. The phase here is important because and again, it's to do with the separation system. If you set up something to the phase of gas and your primary phase is liquids, we pretty much assuming that the capacity of this particular stream is not gonna impact the separation system. So anything prior separation is not gonna be using gas as a reference capacity. Is going to be using liquids, right? So we're going to use millions of standard cube feet, right? And we're going to use the red as the line color, right? So when I press OK, so you get oil, water, and gas. The failure data will be in years, the repair data will be in hours, right? When I press OK, now we need to define our block flow diagram. So when I go to the equipment catalog, I'm gonna fix this up. I'm gonna just, size this up. And what I can do here, I can actually drag and drop my well production, right? And I'm gonna say I only have one well in this model. I have a production platform, right? I'm gonna put my production platform there. Okay. I'm not really worried about the capacities now, and it's gonna make sense in a second. Okay. Then I have my I have another 3 systems. I have the compression system, which is here, right? I'm going to change the name to compression system, right? Okay. I have a water export system, right? Right? And I can say I have a, let me just put this a bit to the right. And let's say we have also a oil export system. So we call it oil export system, right? So we have 3 nodes there. So this was a bit overlapping, so I can move this down, and there you go. So as we described before, we need now to connect this, right? So the connection tool is available on the home tab. So if you click on this, we can see the mouse cursor is going to change, right? So there you go. always connecting from right to left, from downstream to upstream, right? So the first step is connecting the production platform to the well. When I drop my, when I click on production platform and drop the line, hold my left button and drop the line on the well, what we're gonna see, we have a new option, compared to the single product model. Now we need to decide what we're gonna separate here, right? But from the well to the production platform, we have an unseparated stream, right? So there you go. So we have the first connection there. When I connect the oil export to the production platform, right, I now can actually separate the oil. So what I'm saying to Maros is, Maros, look, all the streams, all the production of oil coming from the wells through the production platform is going to go to this oil exports, right? And you can see it's a dark green there. Now let's separate the water. The water is there. And now the remaining is the gas, right? So there you go. I can actually, adjust my lines, and there you go. So it looks much better now. So this is the block flow diagram. Okay, very kind of simple to understand what's happening here. If there is a failure on the oil export, we shut down the entire system, obviously, because we cannot export oil, which is our export node, as you can see here. So the black dot line indicates this is an export node, and the flag indicates it's a criticality node, right? So this is a criticality node, and this is our export node, right? If there is a failure on the water export, there will be an overflow in the separation system, and we need to shut down. If there is a failure in the compression system, we need to shut down as well, because we don't have any flaring defined. If you want to know how to model flaring, please refer to our flaring modeling video, right? All right, so following the steps we did in the building up your model in 6 steps, let's now define the production profile for each one of the products, right? When I go to the flow grid, what I can see, let me just hide this now. I can see the well, and now I can see 3 tabs at the bottom: oil, water, and gas, right? So now I need to define the production rate for each one of the streams, right? So let's start by the oil. Let's say oil, I have 100,000 barrels, right? Let's say for the water, we start by pumping, let's say 50,000 barrels, but after 5 years, okay, so I can just select here, after 5 years, I can, there is an increase which goes to 100, right? And let's say for the gas, I want to enter a series of 5 rows, right? Each one changing every 2 years. So how do I do that? I can right click, go to insert series, right? Right click on the plus, insert series, and I want to say that I want to have 5 rows, right? With a step value of 2. So I'm covering every 2 years 5 rows, so that's 10 years, right? When I press OK, I can actually say that, for example, my gas production is starting at 100 and it's going down by 5 millions of standard cubic feet every 2 years, right? So 90, 85, and 80, right? All right. So when I press view now, when I click on view, what happens is that Maros is gonna try to validate these capacities, right? And it's gonna say, it's gonna show this error message, right? And it's gonna say the node capacity of 100,000 barrels is not sufficient to handle the defined flow of 200. So where is this 200 coming from? If I go back to my flow grid, you're gonna see that there's a total liquid here tab. When I click on it, you can see that by 2021 we have 200,000 barrels of total liquids running through this system, right? So we need to set up the right capacities, right? So when I go If I click on view again, it's going to flip back to the main view. And if you have like a big model, this can actually be quite of a hassle, right? So in order to avoid, you have to go to all nodes. We set up a new feature which is called the bottlenecking, or removing bottlenecks. So if you go to settings and press remove bottlenecks, Maros is going to say, look, this is going to increase all the capacities in your system to meet the production you have defined in the flow grids. I want to say yes to this. And Maros is going to fix the well and the production platform, but it's not fixing the compression. So why is that? There's another error here, right? So if I right click and go to properties, so there you go. So we forgot to define, so this is a gas related system, right? Unit, node. So we need to define the right unit. So I can go to general and I can say, this is actually a gas unit. So press apply and close. And there you go. So now we have the model up and running. So the next step for us will be defining the reliability block diagrams, and each one of the nodes could have a reliability block diagram. But what I really want to show you today is, let's say we have a water export pump, right? And what I want to show how the varying capacity of the production profile can actually impact in your performance, right? So if I double click on the water export, I'm going to add a system, right? And I'm going to call this water pumps, right? I'm going to double click on this. And what I want to do, I want to add a pump item, right? So I go to my catalog on the bottom and I want to add a pump item, right? So this is a water pump and the tag number is P1001. As I explained in the building up your model in 6 steps video, it's better to enter the reliability data now and then convert the pump into the configuration we want, right? Why is that? Because Maros is going to copy the reliability data and you don't need to enter twice, right? So let's say the water pump is failing, it's likely to fail every year, right? So that is exponential, likely to fail every year. So apart from that, it takes us 24 hours to fix this water pump, right? So there you go. So you can see the error message is now gone. If I move back again to the water pumps, I can say this is a 2 by 50%. So there you go, 2 by 50%. So the model is now fully defined, right? So let's run this model now. So if I press run now, what we should expect to see, obviously only the water pumps failing, right? And we should expect to see the criticality of the system being only to do with the water pumps. But also in the annual production efficiency graph, we should expect to see the varying production loss, because the water pump is failing in different stages of the life cycle, right? So let's run that now. I want to save. And one thing that is actually quite nice, let's just turn on the animation, right? So if generate animation and press run now. Yes. So it runs quite fast, right? So it's just completed the run. So let's look at this, right? So 99.86, right? So it's kind of a highly reliable system. But what I really want to show you is that if I display the annual production efficiency graph, if I display as a table, right? During the first 5 years, we have a 0 production loss, right? Apart from a specific point here, right? Where perhaps both pumps went down. But why is that? Why do we have 0 production loss during the first 5 years, and we have actually losses during the second year, right? A good way of understanding that is trying to understand that is using the animation. So if I go back to the asset view, go to the block flow diagram level, right? And if we play the animation, we can see the first life cycle animated, right? So there's an animation control here. So just so you know, green means that we're utilizing parts of the unit. white means that we have some spare capacity, and when red shows up, it means that we had a failure, right? So when I press event step and I go to my next event, look, the water pump fails. But the water pump fails and doesn't impact at all my system. Why is that? Because I have a 2 by 50% water. So during the first 5 years, right, I only need 1 water available to keep my system producing, right? I jump to the next step, water and no failures, right? Jump to the next step, there's a decrease on the gas production, right? But that's just the well, it's not producing as much. And we keep going. So let's try to go to the year where we have a increase in the capacities here, in the water production, right? So year 5, there you go. Year 5, boom. We had full capacity, right? So everything's producing at full capacity, 200,000 barrels for each one of the well and separation, and water is at full capacity now. So when a failure occurs now, we have to reduce everything to 50%. Why is that? Because if you cannot produce 50% of the entire water production, you need to shut down the separation by 50%, and you need to this is going to impact the oil on 50%, right? So this is why production profiles are so important, right? So hopefully this was helpful, right? And you got to understand a bit more about the production capacities in Maros. If you have any questions, please do get in touch at software.support@dnvgl.com. Thank you.